This is the second side of the word equations worksheet. The first thing you might wish to do is look for any of the diatomics, which you can remember by the Hofbrinkel. So in my first question, for example, I have hydrogen and oxygen, so I will fill those in as H2 and O2. I have a hydrogen alone in my second question. I have an oxygen alone in question 4. Chlorine is by herself in question 5, and so is iodine. However, when they are combined with potassium chloride or potassium iodide, they don't get written with the 2. They will get written with whichever number charge on the metal does the crisscross. I'll show you those when we get to them. The first one's quite simple. Hydrogen plus oxygen make water, so we fill in H2O. The next step would be to go back and balance this equation. I'll do that in red. I have 2 oxygen, and I will need to make 2 oxygen, so a 2 there. That gives me 4 hydrogen on this side. Those 2 together make 4, so I'll need to put a 2 here. That will give me 4 hydrogen on the other side. Iron 3 oxide, I want to start by writing my formula correctly, so I'll go to the periodic table, and this is iron 3 because the Roman numeral tells me. Oxygen I need to look up, it's a 2. So when I do my crisscross, the 2 into the middle and the 3 will go to the end. Plus sign between the hydrogen. Water is H2O plus iron. Okay, iron does not get a 3 here. When it's written by itself, it's just a symbol. You don't need to worry about the Roman numeral. The next step would be to balance this one. So if I see that I have 2 Fe here, I need to put 2 Fe there. And I have 3 O's here, so I will need 3 here. This 3 is for the O. It's also for the H2, so 3 times 2 means I have 6 H's. I will need to put a 3 here. Question number 3, I think you should pause the video and try it on your own. It isn't very difficult. It does have a Hofbrinkel in it, so you might want to find that one first. Pause the video, give it a try. Sodium is Na plus water, H2O. Now sodium hydroxide, if I don't know hydroxide, I'd look on the back of the table and find that it's OH, and it's -1, sodium is +1, so those two don't need any numbers, they cancel. Now there's hydrogen, that's my pesky Hofbrinkel. I need to make sure I write that as H2. Balancing this one is a little more challenging because the hydrogen here is not in 2's. So I want to make 2 because hydrogen likes to travel in pairs. That's going to give me in total 4 hydrogen here because I have 2 there and 2 with the H2, so I need 4 here. I can fix that by putting a 2. I also need to put a 2 with the sodium. Question 4, calcium carbide, you need to use the formula that I gave you, which is Ca2C, because carbon doesn't have combining capacity on your sheet, so it makes it slightly more difficult to do. Its real combining charge is -4 and calcium is +2, so when you work that out and reduce it, you get Ca2C. Calcium here is Ca, carbon dioxide, CO2. If I start counting atoms in this one, I can see that I need a 2 for my calcium there, but everything else seems to balance quite. And my very last one that I'll do on the simple, and then we'll move on to more difficult ones for the next video. Potassium iodide is Ki. I can check that potassium's +1, iodine is -1, so I don't need any numbers in that formula. Potassium chloride is KCl. Same thing, potassium is +1, chlorine is -1, plus I2. Iodine, remember, was a Hofbrinkel, and so was chlorine. We filled them in earlier. Okay, I have 2 chlorine here and only 1 on this side, so I want to put a 2 here. That 2 is also for my K, so it goes there. And that 2 also is for the I, which on the other side already has a 2, and that's my clue that I have done that question correctly. The more difficult questions on the bottom of the sheet I will cover in Word Equations 3.